So that means that if we solve this, 2x plus 1 would be 0, so 2x is negative 1, so x is negative a half. So we know that x cannot be negative a half. Now, the thing to remember in solving rational equations is we want to eliminate the denominator. And you're going to do that by multiplying by some common denominator. So that's kind of the strategy for solving any of these, is to multiply by a common denominator. So looking at this particular question, what would be my common denominator? I have to look on both sides, right? So my denominator on the left would be 2x plus 1. What's the denominator on the right? Just 1, right? So the common one would be 2x plus 1. So I'm going to take the whole equation, both sides, times 2x plus 1. Right, so I take every single term by that. Well, this is pretty easy because on the left side, what happens? It cancels out, so I'm left just with x plus 2. Then on the right side, there's nothing that cancels out, so it's 1 times 2x plus 1. So, x plus 2 is 2x plus 1. Then this is a linear equation to solve. We can, let's see, subtract 2x from both sides. And what? Subtract 2 from both sides. So negative x is, so x minus 2x is negative x. And 1 minus 2 is negative 1. So x equals, no, we can't see that. So x equals 1. Right, and again, I got to make sure, of course, that I don't come up with that negative a half, because then I'd have no solution. I can't have anything that would make the bottom 0. And that's it. So let's do one that's a little more difficult. Alright, number 2, I've got x divided by x minus 2 plus 1 over x plus 2 equals 8 divided by x squared minus 4.
Why did you make it like 1?
Why do what?
A regular 2, which would be
A regular 2.
Yeah.
Oh, it should be a b?
Your mom.
Let's do that. Yeah, b may fit better. Okay. So again, same type of strategy as before. I want to multiply by a common denominator. What would be my common denominator this time?
X plus 2. X minus 2.
Right, times that, right? Because often you have one like this, you may want to take and factor out this denominator, which this does factor into x minus 2 times x plus 2. So I'm going to take everything times that, and I would suggest, again, leaving those as two separate factors. So I'm going to take everything times x minus 2 times x plus 2. I just go through each term, right, and say, well, I multiply by this first term. Yeah, the x minus 2's cancel out, so I have x times x plus 2. And then the x plus 2's cancel out here, so I have 1 times x minus 2. And finally, this last one, both cancel out, so I'm left just with 1 times 8, right? And so, again, when you multiply by that common denominator, it gets it down to, if you do it correctly, you get that linear equation. Now it's just a matter of multiplying through. So I have x squared plus 2x plus x minus 2 equals 8. And what type of equation we have to solve now? This is a quadratic, and how do we solve quadratics? We can use factor a quadratic formula. We always set them equal to 0. So we'll subtract the 8 from both sides and then combine like terms. So I have x squared plus 3x minus 10. So I have to ask myself, let's see, will this factor? It does, right. Which is nice. So x and x, and I have what, plus 5 minus 2. So x would equal 2 and negative 5. Now I have to always go back and check, right? Do any of these make the denominators in any of the problem equal to 0? I have to must go back and check. Right, so I look back and says, oh yeah, 2 does, right? 2 right here and right here would make the denominator 0, so I cannot have a 2. How about negative 5? Negative 5 is good, so I have negative 5. So that my final solution then would be that x equals negative 5. Okay. So x is negative 5. All right, I got one more. Then we'll move on to the inequalities. Okay, so inequality, one more equation yet. Number, call it C, right? I've been doing letters. So C. On C I have x divided by 2 minus x plus 2 over x minus 5 equals 0. So again, rational equation. I see I have denominators of 2 minus x, of 1, and you can consider this to have denominator as 1 as well. So what should I multiply by?
X times 2 minus x.
Yeah, we have by 2 denominators. And you can always do it that way. You know, if you don't see a common factor, you can multiply by the whole thing. So I'm going to take everything times x times 2 minus x. Okay, so I just go through, and so on the first one, see the 2 minus x cancels out. So what's left is x times x. Plus 2 times, and now this one, the x's cancel, and it's 2 minus x. Nothing cancels on this one, so it's 5 times x times 2 minus x equals, and nothing cancels here, so it's 0 times x times 2 minus x.
And that makes 0.
Yeah, so then when I distribute everything through, I have x squared. Distribute the 2 through. 4 minus 2x. Distribute this negative 5x through, right? So it's minus 10x plus 5x squared equals, and you're right, that's going to be 0.
I didn't have minus 2x. I did. I had minus 5x and plus 5x. Thanks, Taylor.
Yep.
We needed to know that.
So I'm going to combine like terms. What do I have? X squared and 5x squared would be minus 12x plus 4. Okay, so I've got this. What's my next step on this? Yeah, before I try to factor, what can I do to get even smaller numbers yet? I can take a, not 3, but what can I take out? 2, yeah, these are all even. This is like 2 times 3x squared minus 6x plus 2. So I can divide everything by 2. And then, right, I got to decide, okay, can I factor this? This would be 3x and x, right? Now, can I have factors of 2 that add up to be 6? And no, that doesn't work. What's my next choice? Quadratic formula, right? So I'm going to have to use quadratic formula. So x will equal opposite of b, so it'll be 6 plus or minus a square root of b squared 4ac 2a. $36 minus 24 is 12. I can clean this up some because square root of 12 would be 2 root 3. I can factor what out of the top? 2 out of the top. So that's 2 times 3 plus or minus root 3 over 6. And that goes into 3 times. So final answer is 3. So x equals 3 plus or minus root 3 over 3. I still need to ask myself, will any of those make the denominator 0 in the original question? That's pretty obvious here that they can't, right? Because the only thing would be 0 and 2, and that's none of those. So we have these two solutions. They are rational solutions. Okay, so that's equations. Now we're going to go to inequalities, which are a little more involved in solving, as you can guess. So I'm going to kind of walk you through the basic steps of this. Alright, so the first thing you must do, so it's the A, basic steps. Alright, the best way to do this is always to compare the inequality to 0. Right, so it's not, you can rewrite it so that that happens. Sometimes they're written that way, but so rewrite a rational expression to 0. So that's what we want to start off with. Comparing it to 0. The second thing that helps a lot on this, the easiest way to do this is to write it as a single rational function, not separate fractions added or subtracted. So you're going to write the rational function as a single rational function. Right? That means, of course, you need to get a common denominator. Okay, so you get common denominator, you're going to write this as a single expression. Okay, then you're going to find the values where both the top and bottom of your expression are equal to 0. And finally, you're going to use test values to determine the intervals where the expression is positive or negative. Okay, so that's kind of the steps you go through. So it's much more involved than what we did before. And not difficult, probably more tedious and difficult. So let me run through a couple examples on this. Okay, first one. I want to solve x plus 2 divided by 2x plus 1 is less than or equal to 1. Okay. So, based on what we've just talked about, what's my very first step on this? Right, I need to compare it to 0 because right now, right, this expression is compared to 1, right? So how do I compare this to 0? I subtract 1 from both sides. So if I subtract 1 from both sides, I have x plus 2 over 2x plus 1 minus 1 is less than or equal to 0. Okay, so first step, compare to 0. What's my next step? Okay, I need to write this as a single expression, right? Not as 2 added or subtracted. So I have to get a common denominator. What's my common denominator? 2x plus 1, right? So my common denominator is going to be 2x plus 1. So I take the 1 times, well, it's pretty easy, 2x plus 1 over 2x plus 1. So when I get that, I have on top would be x plus 2. Y just times this. Times just the 1. As opposed to doing what?
You're just finding the common.
I'm kind of common on if I can subtract these two fractions. So, yeah. Yeah, so, right, unlike so an equation we multiply by the common denominator, right? But that eliminated the denominators. We can't do it with inequality because that would eliminate possible solutions. So we have to keep that. So I can't do it that way. If I distribute my negative through, I get minus 2x minus 1. So I end up with on top is, let's see, I have x minus 2x would be negative x plus 1 over 2x plus 1. So there's my problem now compared to 0 in a single expression. What's my next step? I need to find out where it's equal to 0. So where the top is 0 and where it's undefined, where the bottom is 0. Right, a fraction is equal to 0 where the top is, where negative x plus 1 equals 0. So negative x would be negative 1, so x would be 1. So at 1, this is equal to 0. I also look where it's undefined. Right, because you ask yourself this question, right? If it's less than or equal to 0, right, it's either equal to 0 or it's undefined. Undefined is not less than 0. So where's it undefined at? Well, with the bottom, right? Where 2x plus 1 equals 0. That's where x equals negative a half. Okay. So what we do next is we basically put these things on a number line. So we know that because we have range of solutions, right? So if I think of a number line that stretches from negative infinity to infinity, these are all the possible x values we could have. At 1, it's equal to 0. And you ask yourself here, is that a solution to this? Would 1 be a solution? Actually, it would be because I have this equal sign here. So I'm going to put an open dot there. Then I also have negative a half. But negative a half is where it's undefined. That can never be a solution. So I'm going to put an open circle on that. Finally, this gives me these intervals. And in these intervals, right, this expression is either positive or negative. And so we use test values to figure out which one it is. So, test values, we need to pick a value and see what it is. And so what would be a good test value in this area, this interval? Negative 1. We're going to let x equal negative 1. Then I'm actually going to plug that into my expression. Plug that into this. So I have negative times negative 1 plus 1 over 2 times negative 1 plus 1. So that's what equals, the top would be actually 2, the bottom is, so that would be negative. The test value in this region. Let's let x equal 0. 0 is always a good choice if that's in that interval. So it would be negative 0 plus 1 over 2 times 0 plus 1. So that would be 1. That would be positive. And then finally, in this region, what am I going to pick? 2 maybe?
Didn't you use 1 since it's
Well, no, because we want to have something in the interval. So 1 is a solution. We'll see what happens in the interval. Something in that interval, and 2 would be a good choice. So we'll let x equal 2. So we have negative times 2 plus 1, 2 times 2 plus 1. That's going to be, yeah, so it's going to clearly be negative. And remember, we don't, on these test intervals, we don't care about the actual value. All I care about is positive or negative. So just calculate as much as you need to figure that out. Okay, so what's my solution going to be to this problem? I'm looking for what values?
negative values.
Yeah, go back up here, right? We said where this expression was less than or equal to 0. I'm looking for the negatives. So it's negative from negative infinity up to negative a half. The negative a half is not a solution. That's why I put that open circle. So I'm going to put an open bracket on it. And then it's from 1, but 1 is a solution, square bracket, to infinity. Okay, questions on that? Okay, I'm going to stop there for today. Tomorrow we have